Yes, R4 is dealing with rational expressions. So rational expression, okay, what does it mean? Well, right here at the beginning of the word, part of rational, you see ratio, right? So ratio means, well, I've just got two numbers that are divided, right? So because of that, what is a rational expression? It's a case where I have a numerator and a denominator, and I have a variable sitting in the denominator for the most part. It doesn't have to be there. All I gotta have is a numerator and denominator. If there's no variable in the denominator, you can rewrite as a fractional. So if I have 2x over 3, that is a rational expression, but I wouldn't deal with it as a rational expression. I would write it as 2x over 3. If I have 2 over 3x, I can't do that. That's not the same. I can't pull that out. I can't pull the 2/3 out front or call that the coefficient because x is sitting in the denominator. So these are really mainly cases where there's a variable in the denominator. The problem tells me to simplify these, which means just divide. Divide if possible. So my first one here, my numerator is 3x cubed y. Denominator divided by 27x to the 4th. So do your division. 3 and 27 both have a factor of 3. You might think you printed the wrong notes. No, this one should match up. Now the writing at the top would be R4. Your notes look like R4 and it looks handwriting is the top, but the problem should still match up. Is that not the case on the printed notes? All right. Oh. All right. Well, let's go with it. And again, like I said, we got the video, but check under the guided notes for R4 and see if at least the problems line up. But let's go ahead and do this division here. 3 and 27 both have a factor of 3. 3 divided by 3 is 1. 3 divided by 27 is 9. All right. I've got x's in common. This is x cubed. This is x to the 4th. Both of these have an x cubed in common. So x cubed divided by x cubed leaves me a 1. X to the 4th divided by x cubed leaves me what? X to the 1st, or just x, right? When I'm dividing the same base with different powers, I subtract the powers, right? So x to the 4th divided by x cubed leaves me x to the 1st. Y is still in the numerator. It's not in the denominator. It's not going to simplify out. So what are my remaining factors? I have 1 times y in the numerator. The denominator, I have 9 times x. I'm showing you way more work than you need to see because the 1s are not going to be part of the final answer because 1 times 1 is 1. 1 times y is y. Denominator 9 times x. It's just 9 times x. And that's it. All right. So next, we've got a little bit of work to do here. 2x squared plus 7x minus 15 divided by 4x squared minus 12x plus 9. Both of these will factor. All right, 2x squared plus 7x minus 15. I'm going to go ahead and do the factoring for you. Because both of these have a coefficient that is not 1. But the numerator factors into x plus 5 times 2x minus 3. If you want to, absolutely check. Multiply these back out and see if you get your numerator. And then the denominator is, well, it turns out this is a perfect square, right? x squared minus 12x plus 9 factors into 2x minus 3 times 2x minus 3. And then again, I know I'm going fast. I know I'm scooting past the work here, but that's just because I'm behind in the lecture. 2x minus 3 is divide away, and I'm left with what? Got x plus 5 in the numerator and 2x minus 3 in the denominator. When I make the video, I will go back and show you the bottoms up method to show you the factoring for those middle ones. But I think the goal here is not testing your factoring skills so much as it's just making sure that we can simplify rational expressions. The last one. Now, this one, the numerator, you may not see it immediately, but it is the difference of cubes. All right, and the difference of cubes is what? Sorry. Difference of perfect cubes. I cannot write with this. There we go. There I am. All right. So the difference of cubes says if I have two perfect cubes, that this will break down into a minus b times a squared plus 2ab plus b squared. This is just a rule from the textbook. It is not a situation where you just know that off the top of your head. So do I have this? Yes. Yes, I do. I have it right there. M cubed is just m times m times m. 64, that's probably the tougher one. The cube root of 64 is 4, right? So that means m cubed minus 64 is going to break down into m minus 4 times m squared plus 2 times m times 4 plus 4 squared. So everywhere there's an A, I'm putting an m. Everywhere there's a B, I'm putting a 4. That cleans a little bit. M squared plus 8m plus 16. Now, that is my numerator. Okay. How about the denominator? All right, let me just make a note here. Just so we don't lose ourselves. The easiest thing to do in math is when you apply one step, you get to the end and people are like, yep, I'm done. No, that was to simplify the numerator to see if there's any more work to be done. So don't immediately think you're done just because you've reached what's not. This doesn't answer the question that was asked. What's the denominator? The denominator is 16m minus m cubed. Now, is this the difference of perfect cubes? The second term is, but the first term is not. All right, so what can I do instead to factor here? Well, both of these have a factor of m in it. So I'm going to factor out that m. It's going to leave me 16 minus m squared. This is the difference of squares. 16 squared is 4. M squared is m. Or square root of 16 is 4. The square root of m squared is m. So that means this breaks down into 4 minus m times 4 plus m. Backwards, isn't it? We're used to seeing m minus 4. Yeah, that's exactly it, Andrew. You're used to seeing m minus 4 and m plus 4, but my difference of cubes are backward. My difference of squares are backwards. 16 is the first term, m squared is the last term. So I have to follow that pattern. So instead of having m minus 4, I have 4 minus m. Instead of having m plus 4, I have 4 plus m. So this is my simplified denominator. So all that work off to the side, which is why scrap paper is absolutely necessary in math. And what do I have? I have my numerator is m minus 4 times m squared plus 8m plus 16. My denominator is m times 4 minus m times 4 plus m. Are there any common factors? Yes, the order. So it looks like it, right? So let's write that denominator. Let's get those m's in the order that we're using them. So m minus 4 times m squared plus 8m plus 16 divided by m times, now that is negative m plus 4 times m plus 4 and 4 plus m are the same thing because addition is commutative. Okay, now these are not exactly the same yet, right? These aren't exactly the same, but they're close. How close are they? Well, they're just switched signs, aren't they? M minus 4, negative m plus 4. That m and the 4 just have opposite signs. Well, if they both have opposite signs, what if I factor out a negative from this, from negative m plus 4? Factoring out a negative swaps the signs. So negative m becomes m, positive 4 becomes negative 4, and now they match, right? So I'm going to write that out. I'm going to keep writing the numerator because it is important that this keeps going. So numerator, m minus 4. If you're trying to figure out how do I know I'm not done, how do I know I need to go on? Well, if this is going to reduce anymore, m squared plus 8m plus 16 is not going to factor. So the only way this is going to factor is if that m minus 4 somehow goes away or somehow divides out. So I've got the negative 1 that I factored out times m minus 4 times m plus 4. Good. And now we can divide the m minus 4s away. Those leave 1s. And what am I going to be left with? I'm going to be left with, the numerator is m squared plus 8m plus 16 over, I think you're right, Andrew. I think I have factored this wrong. I think this is 2 times a times b. Yeah. No, 2 times 4 is 8. This is right. This is your 8s. But it doesn't. B is m is 2 times 4 is 8. 2 numbers multiplied is 16. And it does factor. Well, look at that. All right. I'm glad this one's on video because we're going to have to chase down the answer here. All right. Andrew's right. Andrew's mentioned that my trinomial that's left over actually does factor. So in the numerator, I've got, let's get the step we were doing done first. In my notes, I had that as 4m in the middle. That's why I didn't see it. And the denominator is negative m times m plus 4. Now, Andrew said that the numerator is factorable. Two things multiply to 16 and add to 8. Yeah, that's 4 and 4. So the numerator can be rewritten as m plus 4 times m plus 4. The denominator is still negative m times m plus 4. Same thing as last time, right? I got the same factor in the numerator and the denominator. They divide away. And what's left? What's left is m plus 4 divided by negative m, or negative m plus 4 over m. Okay. All right. So, can I go any further than this? No, I can rewrite that is m divided by m plus 4 divided by m, but that is perfectly fine the way it's written. I cannot divide those m's. Okay, I know there's a temptation to do it. I still feel that temptation every time I do a math problem, but I cannot divide these m's out, because in order to divide an m, all the terms of the numerator and all the terms of the denominator must share it. So that's as far as I can go. That is the answer, negative m plus 4 divided by m. And what I said earlier is I have a single term in the denominator, so I could rewrite this as each piece written, m divided by m is 1. And then this would be, because the minus goes to both. So negative m divided by m is negative 1. 4 over m is 4 over m. That is the finalized answer. I like that one better, though. They're the same thing. All right. So what's next? Let's take a look at the one up here on the at the top left with the practice. To simplify, 8x minus x squared over x squared minus 7x minus 8. Okay, lots of work to do here. First thing always when I'm trying to factor, do I have a common factor? Yeah, the numerator has one, right? There's an x in both of those. So factor out the x. That's going to leave me 8 minus x. That's so much easier than having to factor all the way out, right? That is factoring, but that's much easier than factoring out a trinomial. What about the denominator? X squared minus 7x minus 8 multiplied to negative 8, add to negative 7. Yes, Emma, I did. So Emma asked, did I factor the negative 1 out of just the negative m plus 4? That's exactly right. Mm-hmm. All right. 8 and 1. Yep. 8 and 1. And I'm multiplying to negative 8, adding to negative 7. So that means I know the numbers are 8 and 1, and which sign goes with which. If the middle term is negative, the magnitude of the negative number is larger than the magnitude of the positive number. I know they're opposite sign because they multiplied to a negative. The sign of the middle term tells me that not only did they multiply, when they multiplied, they came out negative, but when I added them, the result was negative. Okay, same thing that we saw in the last one. I have what look like the same thing, or they're just off by a sign. Right, I have 8 minus x over, and now that I think out loud, you're used to seeing the x plus 8. So I'm going to factor that negative out up here instead of factoring out of the x minus 8. Now, it's going to feel like that works all the time, and it doesn't. So when you're doing those problems, if you get one of these cases where you can divide or you can factor out a negative and it swaps the signs, take a second look and make sure that you're right. Because the temptation is to, once you've seen that trick, always there, and that doesn't always happen. So end up with negative x over x plus 1. Why did I do that? All right. Yes, that one was quite a bit easier, I agree. All right, so this is working with rational expressions. Questions. And again, you can send them to the everybody chat, or if you just want to send them to me, you can send them to that LT questions. Okay. All right, so let's go on to the next page. And this is the bottom of the page if you're worried. Next is adding and subtracting rational expressions. All right. So in order to add and subtract, that's going to do that 14 times. What we have to do is, in order to add or subtract anything, we have to have the same denominator, right? So in order to add and subtract rational expressions, I've got to have the same denominator. To have the same denominator means I'm going to find the least common denominator of both or three or all the terms that I'm dealing with. And I'm going to multiply each term by whatever I need to make the denominator I want. So let me, again, when I talk it out loud in math, it doesn't really help. It's because it can just get jumbled and confused. So instead of talking it, let me show you what I mean. So for this problem, I have 7 over 4a plus 11 over 10a squared. Okay, what is the LCD here? LCD is the least common denominator. It is the smallest multiple that both denominators will go into. They're easy to find when you have two numbers. When I throw variables in, people get a little bit afraid. So Andrew has mentioned that it's 2a. 2a is the least common multiple, or excuse me, the greatest common multiple. That's the largest, or the factor that has the most terms that go into the denominators. But what I want is the LCD. So to get the LCD, I'm going to take my denominators, and again, I'm doing more work than I need to see, and break them down into what's called their prime factorization. So if it's 2 times 2, and a is a, so that's one denominator. For the next one, the other denominator is 10a squared. Break down 10 to its prime factors, it's 2 times 5, right? And then a squared is a times a. So these are the prime factorizations of the two denominators that I have. If I want to find the LCD, what I do is any factor that appears in both or all of the denominators I'm looking at is multiplied once. So there's a 2 and there's an a in both of those. So I multiply by 2, I multiply by a, and then every factor that's left, I multiply by that once. So the 2 from up here comes in, the 5 and the a. Multiply that all together, and what do I have? 2 times 2 is 4, 4 times 5 is 20, a times a is a squared. So this is the LCD. All right, so that's the denominator that I want each of these to end up with. So how am I going to do that? Well, remember I told you that, I told you last time that yes, I need to get them to the same denominator. And I told you that one trick in math that's something that you always see is find a clever way to add 0. For this, I need a clever way to multiply by 1, right? So to multiply by 1, I have 4a, I want 20a squared. Well, to get 20a squared, 4's got to be multiplied by 5 to get 20. A's got to be multiplied by a to get a squared. If I do it to the denominator, I have to do it to the numerator, because here's the other main trick we use in math. This is a clever way of multiplying by 1. So plus, and then what's my other term? 11 over 10a squared. 10a squared, LCD is 20a squared. The only thing it needs is to be multiplied by 2. All right, so let's do the math. And 7 times 5a is 35a. 11 times 2 is 22. Now, here's the key feature. Remember, I did all that work so that I would have the same denominator. Both of these fractions have a denominator of 20a squared, so I can write it all over the same denominator, because that was the goal. That was what I was trying to get out of it, is to get the same denominator. Now, if you are looking at that and saying, oh, I can rewrite those, I could rewrite this as 35a over 20a squared plus 22 over 20a squared. You could, but that would just undo all the work we just did. So we don't want to do that. Okay. So as we get into R4 here, the tough part again is going to be figuring out when we're done, right? Because this problem says to add and simplify. Well, this is simplified. All right. How about example 5? Okay, example 5 has quite a bit more work, but I think we're going to be okay. So subtract the rational expressions and simplify the result. So I have what going on here? I have, first, I want to see if I have any division that I can do, right? I've got 2 rational expressions here. They're subtracted. 3x plus 5 over x squared plus 4x plus 3 minus x minus 5 over x squared plus 2x minus 3. So I'm going to jot these down up here really quick. I'm just going to grab the denominators for now. X squared plus 4x plus 3. That factors into x plus 3 times x plus 1. My other denominator is x squared plus 2x minus 3. That factors into x plus 3 times x minus 1. All right, so this was the denominator of the first. This is the denominator of the second. And what did I do last time to get the LCD? If there were any factors that were shared, I multiplied by them once. Any shared factors here? Yeah. X minus 3 appears in both. So I'm only going to write that once. I said minus, but I meant plus. I'm sorry. X plus 3 appears in both of my prime factorizations. Now everything else only appears once, so that means I've got the x plus 3 times x plus 1 times x minus 1. That's my LCD. It doesn't look like an LCD because it's hard to remember that x plus 3, quantity x plus 3 is a single number. Doesn't look like it, but it is. Because if I give you x, before you can do any math here, you're going to add 3 to it. So that is a number. It's just, what is a number? Well, it's whatever x is. When you give me x, add 3 more. So this means I've factored my denominators. So I can rewrite my denominators. So the first term here is 3x plus 5. I'm dividing by x squared plus 4x plus 3. Well, we just did the work and said that this is x plus 3 times x plus 1. I want x plus 3 times x plus 1 times x minus 1. How do I do that? Well, I multiply by it. If I multiply the denominator by x minus 1, I'll have my LCD. I'm allowed to do that as long as I do the same thing to the numerator, right? And that's a critical step. You've got to do the same thing to the numerator. Minus, what have I got over here? I've got x minus 5 divided by, what is my denominator? X squared plus 2x minus 3. Well, that was factored into x plus 3 times x minus 1. What is it missing? It is missing the factor x plus 1. So I'm going to multiply by that. And what do I have now? Well, three x plus 5 times x minus 1 minus x minus 5 times x plus 1, all divided by x plus 3 times x plus 1 times x minus 1. Multiply, so I've got following the order of operations, the numerator has some multiplication to do. I'm not going to multiply out the denominator because I want to leave this in factored form if I can. The numerator, remember the whole goal here was to do subtraction. The whole goal of this problem was to actually be able to subtract those two pieces, right? Subtract my two rational expressions. So I still need to do the work up here. I need to multiply the numerators. So I'm going to do that. 3 plus 5 times x minus 1. That is 3x times x is 3x squared. 3x times negative 1 is negative 3x. Inner is 5 times x, which is 5x. And 5 times negative 1, negative 5. Minus x minus 5 times x plus 1 is x squared minus 5x plus x minus 5. And again, this is all divided by x plus 3 times x plus 1 times x minus 1. Okay, now you can handle the next step, or let's combine like terms first, and then I'll tell you the next step. Anytime you do that trinomial, always look to see if your middle terms are like. If they are, go ahead and combine them. Negative 3x plus 5x, negative 3 plus 5 is 2x. And in the middle here, I have negative 5x plus x, which is negative 4x, and minus 5, all divided by x plus 3 times x plus 1 times x minus 1. Now, next step. Notice I keep writing that last, that second trinomial in parentheses. That's because this subtraction applies to the result of x minus 5 times x plus 1. So that means this needs to be distributed to each term. So what do I have now? I now have 3x squared plus 2x minus 5 minus x squared minus negative 4x, which is plus 4x, minus negative 5, which is plus 5, all divided by x plus 3 times x plus 1 times x minus 1. Let me say it again. We're going into more detail than I need to see, because if you can stop here and say 3x squared minus x squared and do the process that way, that's absolutely fine. But let's combine like terms now. 3x squared minus x squared leaves me 2x squared. 2x plus 4x is 6x. Negative 5 plus 5 is 0. So my constant term goes away. My denominator is still the same. X plus 3 times x plus 1 times x minus 1. Is there any more to do here? Look at that numerator. It's a binomial, but it has some common factors. So let's get those out, right? We need to be in factored form. 2x squared and 6x both have a factor of 2x. And what is that going to leave me? 2x squared divided by 2x is x. 6x divided by 2x is 3. Hey, wait a second. It's like I knew this was going to happen. And look at that. So why didn't I multiply out the denominator? 1, I didn't want to. And 2, if I'm trying to write this in factored form and simplified, I would have never seen that division right there if I had multiplied this out. So divide those, that leaves me a factor of 1. So what do I have? I have 2x over x plus 1 times x minus 1. And I cannot do any more, right? There's nothing left in the numerator to be common with the denominator. I don't even have a binomial in the numerator at this point. Okay? So you've got the 2 skill practice problems there. Again, I'm going to come back and deal with this and work some videos into the problems so that you see everything. But how are we feeling about this? These seem long, don't they? Whenever I have these, whenever I'm adding and subtracting rational expressions, the problems can get long. And that is, yeah, these do feel better. That's good. Okay. So yes, they can get long. Yes, start collecting scrap paper so that you can do your work on there. This thing has been so annoying. I'm sorry. Good time to mute my phone 5 or 10 minutes before the end of class. But let's go on and let's deal with the next section of R4. All right. Yes, Gabrielle, there are practice problems like this in Alex. So yeah, and then this is in R4. Last bit's in R3. You'll be seeing all of this throughout the homework, and you've got plenty of attempts to tackle it. All right. Good. Can you use a drawing pad? Sure. Sure, you can use a drawing pad for this. Yep. Yeah, I agree. All right, so let's deal with complex fractions now. Now here is, it's odd that that mathematicians weren't more careful here. Complex fraction seems to indicate complex numbers, but it's not. Okay, Emma, I think that I imagine there are a lot of people that feel the way you're feeling, that you know it, but you're not actually learning it right now. Yeah, that you're dealing with, that you're trying to write furiously to keep up, and it's just not, it doesn't have time to sink in. And that's it. This is me showing you how to do it once, and then it's during that practice, during those multiple attempts and trying again, that's when it really sinks in. So I'm just showing you the process once or twice, and then you doing the process over and over is getting it. Yeah. Yes, so what I was saying, complex fractions. Complex seems to indicate that complex numbers are involved, but they're not. Complex fractions are also called compound fractions. All right, and what they mean is I have a fraction in the numerator, the denominator, or both. These are also called, like I said, compound fractions. AKA. So what does it mean? Like I said, it means I have, get the pen off the way here. And this means we have a fraction in numerator or denominator of a rational expression. All right. So how do I deal with these? There are two ways to deal with compound fractions. The first one is to do the math that is set in front of you following order of operations. So for the first one, or for my problem here, I have x minus 4 divided by 4 minus x. Excuse me, said that all wrong. X divided by 4 minus 4 divided by x, all divided by 1/4 plus 1 over x. So in the way it's written right now, I have two problems. I need to deal with the numerator. I need to deal with the denominator. So to do that, I need the LCD of the numerator. What is it? Well, the two factors that make up the numerator are 4 and x. So common denominator I want to get for this subtraction to occur is 4x. How about for the denominator? Well, it's 4 and x again, right? So I need to make the numerator into a fraction that has a denominator of 4x, and I need to do the same thing with the denominator. Yes. So what do I need to do? That means I'm looking at x minus 4 times, I have 4, I want 4x, so I'm going to multiply by x over x minus 4 over x. I have a denominator of x, I would like a denominator of 4x, so I need to multiply that by 4 over 4. Now, this is the numerator of the original. So there's the, oh, straight lines. Straight lines are my enemy today. Divided by, the denominator is 1/4. I want it to have a denominator of 4x. And lastly, 1 over x, I wanted to have a denominator of, I made that mistake. Let me talk it all the way out. So denominator in the common LCD of the numerator is 4x, the LCD of the denominator is 4x. I have 4, I want 4x, so I multiply the first by x over x. Over here I have x, I want 4x, so I multiply by 4 over 4. What does this do? Okay. This does what x times x is, it's x squared over 4x minus, oh, and let's go ahead and do this all in one step. I've got the same denominators. Both of these multiplications are going to result in denominators of 4x. So that means x times x is x squared. 4 times 4 is 16. So there's the numerator. The denominator, 1 times x is x. 1 times 4 is 4. The operation between the fractions was minus in both, so that's why this minus makes its appearance here. So I've got x squared minus 16 over 4x, all divided by x minus 4x. This is division with fractions, okay? No one has ever taught you to divide by fractions. What we've always done is say division is the same thing as multiplication by the reciprocal. Multiplying by the reciprocal is so much easier than dividing by fractions. So what do? Numerator is 4x, x squared divides 16, all divided by 4x. Denominator is x minus 4 over 4x. So copy, change division to multiplication, and then flip. And there is work to be done now, right? So this becomes x squared minus 16 divided by 4x times 4x divided by x minus 4. Is there any simplification I can do here? X squared minus 16 is the difference of perfect squares. So I can rewrite that as x plus 4 times x minus 4. If you were playing along at home, you probably saw that I have a 4x in the numerator here and a 4x in the denominator here. Those will divide away. Absolutely. By factoring that x squared minus 16, I can now see that I have a x minus 4 in the numerator and denominator as well. So I'm going to divide those away. And what's left? Well, the numerator is x plus 4 times 1, which is just x plus 4. The denominator is 1 times 1, which is 1. So would you believe that entire problem breaks down into x plus 4? Crazy, right? Questions? Issues? All right. So it is 2:13. Starting another problem is probably not the best idea, but I'm going to do it anyway. I'm going to start this one because I just want to make sure those negative exponents don't confuse anyone. So what I have here is d to the negative 2 minus c to the negative 2 divided by d to the negative 1 minus c to the negative 1. Now, if you remember, negative exponents mean wherever I am, that is not the right place. If I'm in the numerator, I'm actually supposed to be in the denominator. If I'm in the denominator, I'm actually supposed to be in the numerator. Now, this problem adds an extra wrinkle of difficulty because these are separated by subtraction. So I can't just take this d squared, or d to the negative 2, and put it in the denominator. I need to write d to the negative 2 as 1 over d squared. Moving it to the correct place is what makes the power change signs. So d to the negative 2 is 1 over d squared. C to the negative 2 is 1 over c squared. D to the negative 1 is 1 over d. And c to the negative 1 is 1 over c. Now this looks like the problem we did above, right? That looks like something you've done before. So I'm going to leave this one for you to finish, and this next piece. All right. In this case, my denominator doesn't have a fraction in it, just the numerator does, and it's just one fraction. So to do this problem again, I'm going to find a common denominator. What is the common denominator, the least common denominator here? Well, the denominator of the first term is 1 plus h. What's the denominator of the second term? The second term is just a 2. Anytime you see a number written by itself, we can always write that as that number over 1, right? Because anything divided by 1 just gives you back what you started with. So my LCD is 1 plus h times 1, which is just 1 plus h. So I need to multiply the numerator and denominator of 2 by 1 plus h, combine like terms, and then divide by h. But this will be left for you to do as well. All right, so like I said, I know we're getting behind. I can feel it too. The fact that this is being recorded, I think is going to help. And then once I get my videos, or once I start turning those out and getting some stuff posted to you, that's going to help as well. So any questions out there in internet land before we call it a day today? Any issues getting into Alex? I'll go ahead and stop the recording because that's the end. now. And nice catch, Emma. So right here, yeah, I wrote the problem, and then I went down here to write it again, and I didn't do a good job, because that should be a plus, and that is going to change some stuff, right? So what does that look like? That looks like a plus, which makes this a plus, which makes this a plus, which instead of dividing x minus 4, it divides x plus 4. All right. I am happy to tell you I am not perfect and make mistakes. I do my best to avoid them, but they still happen sometimes. So never feel like you are, I don't want you to feel like you can't say something if you think I did it wrong, because I remember sitting in a CS class and, no microphone. I don't, other than a muted, other than the volume is low, but you can hear all the beeps coming up. Can't think of anything. X plus 4, let me finish this off, get it right. The plus 4 is divide, the 4x is divide. I'm left with x minus 4. Yeah, anything specific. Speakers. All right. Okay, so great catch, Emma. I love it. I left you with, good. All right. So I left you with 2 problems. I ask you to simplify these. These are both rational expressions. Again, expressions, and this is me trying to get the language correct. Expressions do not contain equal signs. Equations contain equal sign. So when I say simplify this expression, this is what I'm talking about. It does not have an other side, or how we say other side of the equation. This doesn't have an other side. Since it's an expression, it limits what we can do. So I can't multiply, I can't find a clever way to add 0 to both sides because there's not 2 sides. So I have to be careful with that. This one breaks down. Let's see. So remember, the negative powers mean it's whenever you see a small child doing something they're not supposed to do, they get that look on their face, like I'm not supposed to be here, I'm probably going to get in trouble. That's all that negative means. I'm in the numerator, I'm supposed to be in the denominator. So it goes like this. So d to the negative 2 is 1 over d squared. C to the negative 2 is 1 over c squared, and then so on and so forth. Now, to deal with this, there are 2 ways to tackle it. We can either multiply the top by the common denominator on the top and bottom, and then find the common denominator down here and do the same thing, or I could find the common denominator for all 4, and this is something we didn't do last time. What is the common denominator for all 4 fractions? Okay, so instead of dealing with the numerator separately, we can do this all in one step. Okay, well, I have a d squared, so least common denominator is going to have a c squared and a d squared. That covers these as well, right? There's no new terms. This is a c, this is a d. Exactly. So since that's the LCD, I am just going to multiply the top and bottom by the LCD. Okay, it's going to prevent the confusion, hopefully, of trying to make the numerator and denominator do different things. And what happens when I do this? When I distribute this, I'm gonna do this in I'm gonna do this out one time, and then we will reduce it, just so you see what's going on. C squared d squared over d squared minus c squared d squared over c squared over c squared d squared over d minus c squared d squared over c. Now, we're clearing the fractions. So if I did this right, the numerator and denominator, the fractions will go away. I won't have a complex fraction anymore. D squareds divide away, c squareds divide away. One of the d factors divides and one of the c factors divide. So what's left? Numerator, I have c squared minus d squared over c squared d minus c d squared. All right. What's next? Ideas? C squared and d squared cancel out. I wish they did, but they don't quite do that yet, because the numerator, both of the terms in the numerator would have to have a c and a d in it, or a c squared and a d squared in it, but they don't. But I can continue factoring. I can continue working. Okay. Well, this is the difference of perfect squares, right? C squared minus d squared. That factors into c plus d, c minus d. The denominator, both terms have a c in it and both terms have a d in it. So I can factor out cd, and that's going to leave me with what? Well, that's going to take away one c and all of the d's. And this is going to take away one c and one d. So I'm left with c minus d and c minus d. These divide. And my final answer is c plus d over cd. So compare that to the way we did this before, where we had I found a common denominator for the numerator, I found a common denominator for the denominator. I got common denominators, I added or subtracted, and then multiplied by the reciprocal. This one goes a lot quicker. Okay. And so let's move this down to the bottom. And let's get this last one out of the way. So I have, and if this is too small, tell me. Pop that out so you can see. I have another complex fraction. That 2 has 1 plus h in the denominator, and then all of that is minus 2, then the whole thing is divided by h. So to do the same, I found the common denominator for all the fractions. So I went through, I looked at them. So the common denominator, the denominators are c, d, c squared, and d squared. C doesn't change, d doesn't do anything, but c squared is c times c, d squared is d times d. So everything that occurs in multiples, we count once. So that means the c's, that's 1. The d's occur, that's 2. And then everything that doesn't repeat anywhere gets counted once, times that c times that d. So now I have c squared, d squared. Okay. All right. So I already mentioned up here the LCD for the numerator of the next problem. So, well, I said it's what? Well, this is, and again, 1 plus h minus 2. I can write, anytime I have an integer, I can rewrite it as itself over 1, because dividing by 1 does nothing. And so I have a numerator that has 2 fractions in it. What's the LCD here? Well, just like the piece before. This has a denominator of 1. This has a denominator of 1 plus h. So my LCD is 1 times 1 plus h, because this doesn't have a factor of 1. I know it's got the 1 plus, but that's not just 1 sitting by itself. So I've got 1 times 1 plus h, which is 1 plus h. So I need to make this fraction I can either see it as make this fraction look like 1 plus h, make it have the same denominator, or I can do what I did before and clear the fractions, right? And to clear the fractions, I just multiply top and bottom by the LCD. I'm allowed to do it because the denominator does the same thing. It's got a 1 down there as well. So we know that 1 plus h is the LCD. So multiply this through, and I'm going to get 2 minus 2 quantity 1 plus h over h times 1 plus h. Now I did 2 steps here. I multiplied every numerator by 1 plus h. The 1 plus h is divided for the first one. That's where this 2 comes from. The 1 plus h does not divide here, it just stays on top. So that's where I get the 2 times 1 plus h. And in the denominator, h times 1 plus h is h times 1 plus h. Do not multiply through until you've completely factored everything, because you may have a common factor that you'll miss if you're not careful here. So numerator has 2 2's in it, or each term has a 2 in it. So I'm going to factor that out. And then here's the toughest part. When I do that, take this 2 away, divide by 2 is 1, minus 2 divided by 2 is 1. And then in the denominator, got h times 1 plus h. Well, I can do some subtraction here, right? Now that that 2 is gone, I can just distribute that subtraction to the 1 plus h. And now I'm looking at 2 times 1 minus 1 minus h over h times 1 plus h. What is 1 minus 1? It is 0. I'll answer that. And then, so that's 2 times negative h for h times 1 plus h. And what have I got? Have anything in common? Yeah, I can divide these h's. If I divide this h by h, this is a negative h. So that's going to leave a negative 1 here. I divide that by h, it just leaves a 1. And what do I have? I have negative 2 over 1 plus h. All right. So, lots of fun ways to tackle the problems. All right. Specific questions here. Again, I know we're recording, so you can always come back and play this. And now that I have that Loom app, I can make videos really quick. I can actually make them on my phone and submit them, so you can ask me a question and I can just respond to you verbally if I'm away. The videos, I will send them as they pop up. The regular lecture videos are in Blackboard under recordings. I'm going to post those on Loom as well. And let me play with Loom a little bit more, and let me see if I can dedicate a playlist or a group of videos for just the class. Okay. So next I got 2 examples. What I'm going to do, again, we are just burning time right now. So I'm going to tell you that the solution to this is 2x. And the solution to this one works, this skill practice 8, it works exactly like the problem we just did. The solution to this is -1 over 1 plus h. Okay, so I'm going to leave those for you to do, and then I'm going to make these videos to, remember I said do the skill problems that are in the notes. So now that we've run across them, I'll make those videos today or tomorrow and post them. All right, so you should be able to do these, get in there, tackle them. These are just like the problems that we just did on the last page, so you got good examples. Okay, last step in R4 is simplifying radical expressions. All right, so in order for a radical expression to be simplified, again, expression meaning that it's just one side, it's not done on an equation, it's just one side. It's a radical expression. That means that x is in there and it is trapped under a root. It doesn't have to be a square root, just any root. So I cannot have a fraction in the radicand, that's what's under the root, and I cannot have a radical in the denominator. You've heard of rationalizing the denominator? That's what this is. Now, why do we do it? Why do we have to rationalize the denominator? The reason is, one, everybody comes up with the same answer. So for example, if I tell you if I said the answer is 1 over the square root of 2, that would be, if that's the answer to some question I give you. If I multiply this by the square root of 2 over the square root of 2, I now have the square root of 2 over 2. These are equal because all I did is multiply by 1. Right, because square root of 2 over square root of 2 is 1. So I just found a clever way to multiply by 1, and this is also correct. So rationalizing the denominator lets everyone know when to stop, because some people will go here, some people will take a step further, some people might try to do more. We want you to know you can stop as soon as the denominator doesn't have any radicals in it. The other reason that we do it is it's a carryover from before computers. Dividing by anytime, let me back that up. Anytime you have the root of a prime number in the denominator, you're dividing by an irrational number. Irrational meaning the decimal goes on forever and ever. Dividing by an irrational is incredibly difficult, especially without computers. Over here, my irrational is in the numerator. I'm dividing by an integer. That I can do. Remember, before computers, people sat down and they had to go to their tables, and they had somewhere in the table it would say the square root of 2 is approximately, and then it would round it out to decimal places. So that's what you're seeing. You're seeing a remnant of, prior to computers, you're seeing a remnant of the slide rule, but we still do it today. We do it because it makes the answer always a nice number. They're also going to run into some things later on in 172 when you get to the unit circle, where having an integer in the denominator makes dividing up the unit circle a whole lot easier. So how do we do this? What do we do to get rid of radicals in the denominator? Well, the answer is almost always, and I say almost always because there's always an exception, I'm going to multiply to get rid of this root. I'm going to multiply the denominator by its reciprocal, all right? And the reciprocal is just take the exact rational expression you see and swap out the middle operation. So in here, this is positive, or this is plus. So the conjugate of 5 plus 2 root x is 5 minus 2 root x. You don't have to be radical to have a conjugate. Conjugate just means change the operation in the middle. And the reason that we like it, the only reason you would have it, is because when I multiply this, so that's the conjugate, I'm going to multiply by 5 minus 2 root x, and 5 minus 2 root x. What happens? Minus 2 root x over, let me make this a little easier to follow. Well, you probably can deduce that if my goal is to get rid of the radical in the denominator, I'm probably doing something that's going to help me with that process. And that's exactly right. So I got 3 times 5 minus 2 root x over, now we FOIL, right? First, outer, inner, last. And they are 5 times 5 is 25. Outer, 5 times negative 2 root x is negative 10 root x. 2 root x times 5 is positive 10 root x. And then 2 root x times negative 2 root x is negative 4 root x squared. Look at these middle terms. They go away. Negative 10x, negative 10 root x plus 10 root x is 0. Okay. So still dealing with the same problem, 2 root x. And remember, all the work I'm doing right now is in the denominator. And then in the denominator, I have 25. These subtract away to 0. And then I have minus 4. What is the square root of x squared? I'm doing inverse operations, right? I'm taking a square root and then I'm squaring it. Anytime that happens, I end up with exactly what's under the root, right? The square root of x squared is x. Okay. And can I do any more than that? I could distribute the 3 if I wanted to, but there's no need. So that's it. 15 minus 6 root x over 25 minus 4x. And again, remember, the goal here was to rationalize the denominator. The answer does not have to be pretty. In fact, it's not. And that is absolutely fine. So don't let, whether we realize it or not, we kind of let how ugly an answer is determine if we think it's right or not. Don't let that fool you in here. Rationalizing the denominator can make some nasty things appear. All right. So how about this next problem? Okay. This is one of those, if you know, you know. But if you don't, it's okay. I'm just making myself some more space here. Okay, because there's 2 ways to tackle this one. We're dealing with the rationalizing the denominator, so let's stick with the plan. So the denominator has square root of x minus 2. I'm going to multiply by the conjugate to get that root out of there. Multiply by conjugate. I am practicing my handwriting. It doesn't look like it, but I am. All right, anybody want to tell me what the conjugate of the square root of x minus 2 is probably? You know it's going to have a square root. You know it's going to have 2. It's the only thing that changes. Yep. Plus sign, exactly. So whenever I get the conjugate, I just swap out my operation. In the problem, I'm doing minus, so the conjugate must have a plus. And the whole purpose of the conjugate is to make the root go away. Anytime I multiply some radical by its conjugate, what I'm going to end up with is a real number. Okay, or I'm going to end up with a rational number. In the numerator, let's get out of the red here. And I've got x minus 4 times square root of x plus 2, all divided by square root of x times the square root of x is x. Square root of x times 2 is 2 root x. Negative 2 times x is negative 2x, negative 2 root x. 2 root x minus 2 root x is 0. So in the denominator, the middle terms go away. Negative 2 times 2 is 4. I got the root out of the denominator, didn't I? Anything else I can do? Well, actually, there is. Look at that. There's a root, x minus 4 and x minus 4 sitting there. They're both factors. So what happens? Well, they go away, and I'm just left with square root of x plus 2. That was easy, right? It's like my daughter at night, if we pick a short book when it's time to go to bed, she's like, that was quick. That one's not too bad at all. Okay, questions? No? All right, let's tackle the monster problem down here. Yeah, I don't think so. I am partial to it because I enjoy math, but I think you're right. It doesn't seem, it's not nearly as some of the stuff you've already seen us do. Now this one, of course, now this looks nasty. This looks so nasty when you start. You're just like, oh, great. What if the denominator has no second term? When I multiply by the conjugate, I'm always going to get the square of the first term and the square of the, or I'm going to get the, yeah, I'm going to get the square of the first term and the square of the second term. And it's always going to be minus in there too, that result of that multiplication. If it was just x in the denominator, then you cannot divide it. It would just be quantity x minus 4 times quantity root x plus 2, closed quantity, all divided by x. And that's all you can do with it. Okay. All right, so let's take on this beast. Your printout may not be as nice. I've figured out how to import equations, so I'm really working on improving the notes as well. But we have x to the 2n plus 1 minus x to the 2n times y, all divided by x to the n plus 3 minus x to the n times y cubed. Do I have any common factors? Yes. Yes, I do. What are they? Well, in the numerator, we both agree, forget about the variables for a second, everyone agrees that the numerator has x in both of its terms, right? X to the 2n minus 1 is one term. X to the 2n times y is the other term. Remember, terms are separated by pluses and minuses. How many x's are up here? How many times am I multiplying by x? Well, this is 2n plus 1 times, and this is 2n times. When I have the same base and I multiply, I add the powers. So I can rewrite this first term as x to the 2n times x to the first, which I don't have to write the 1, but it's there. Why is that helpful? Okay, well, hopefully it lets you in on the secret that the first term and the second term both have a factor of x to the 2n. How about the denominator? Once again, they both have, they both have an x in it, right? This one has x to the n plus 3, this one has x to the n. Well, using that same logic, I can rewrite x to the n plus 3 as x to the n times x cubed. And now here comes the factoring. It's blatant now. The numerator, both terms share an x to the 2n. So what's left over after I do that? Well, this x is left. This entire factor goes. So all I have is y, and the operator just comes from the problem. In the denominator, I have x to the n's in both. And what's left here? Well, x cubed. That x to the n is completely gone. It divided away. Minus y cubed. Everybody okay with that? All right. Now, both of my factors that I pulled out are x's. So I got the same base. They're to different powers. When I divide the same base, when I multiply the same base, I add the powers. When I divide with the base, or with the same base, I subtract 2n minus n, which equals what? 2n minus n is 1n. So the only thing left, I can divide the top and bottom by x to the n, and now I'm looking at x to the n times x minus y over that x to the n divided away by x cubed minus y cubed. Now, I'm going to try to start my notation here so you can follow me. I never like drawing all the way across the page, so I just kind of put an arrow over here to indicate that I'm continuing. The denominator is the difference of cubes. All right, so let me just write this out again down here so you can see, so I don't do something important in the middle. Okay, the denominator is the difference of cubes. The rule says that if I have a cubed minus b cubed, that this is equal to a minus b times, where'd my problem go? A minus b times a squared plus ab plus b squared. This is the thing that I got wrong last time. So the denominator here is, it's not a and b, but it's x and y. Everything matches up. So that means that denominator will break down into what? Well, the denominator is now, let's make it blue now. That's x minus y times x squared plus xy plus y squared. Does that help? Yeah. Well, I mean, help is a tough thing to say here. There's x minus y's, there's factors of x minus y in the numerator and denominator, so I get to divide those away. So what do I have left? I have x to the n divided by this trinomial, x squared plus xy plus y squared. And if you're wondering, one day I'm going to finally pick if I write my 2's with a loop or if I just write them flat. That day just hasn't happened yet. So maybe it's something that happens in your 40s. I just haven't quite gotten there. Okay. That's one of the more devious problems out of R4. Any questions here? Emma, I just saw what you said. I'm going to glance up and then I'm going to come right back. If there was no minus 2. Let's see here, would x to the n divided by x squared minus y squared? No, it would not. And the reason is that this this does not break down the way that you're thinking it does. Because remember, so what you said is if I had the denominator is what she's saying is, does this denominator become this? And the answer is no, because the middle term is there. The middle term doesn't work the way you want it to, because to break this down, I need two things that multiply to y squared, two things multiply to x squared, and then when I add them together, they have to be xy. So if you think this does this, if you think this is x plus y times x plus y, it's actually x squared plus 2xy plus y squared. Because one xy, there's the other xy. So we put them together, and that 2 is there. That's why that I said this. This is the mistake I made last time. The result of that cube being broken down, this typically does not factor. All right. It would if there was a 2 in front, but it doesn't. But there's not, so we would just leave it exactly like this. And this is a place, so people talk about using Mathway or using online stuff, and I want you to have those tools and to use them, but I want you to use them to check your work. I'm absolutely fine with you getting done with this problem, doing the best you can, and then checking this on Mathway. That is not a concern. I just don't want you to get used to looking at Mathway for the answers, because obviously you can't do that on the test. So this is a great problem where this one has a lot of things, there's a lot of moving